Welcome to today's session on iSCSI. We're going to dive into the conceptual side of iSCSI, including how it works, its benefits, and common use cases. By the end of this presentation, you'll have a solid understanding of why iSCSI is a valuable tool in modern IT environments. iSCSI is a network protocol that allows servers or computers to access storage devices as though they are directly attached to them, even if they are physically located far away. This is achieved by sending iSCSI or Small Computer System Interface commands over an IP network, typically using Ethernet. Unlike file-based protocols like NFS or SMB, iSCSI or Internet Small Computer System Interface operates at the block level, meaning it interacts with raw storage directly, which makes it feel like a local disk. At the core of iSCSI are two primary components. The iSCSI target is the server that shares storage resources, often in the form of a virtual disk, LUN. The iSCSI initiator is the client or system that accesses the storage over the network. The initiator sees the storage as though it's a local disk, even though it might reside on a completely different physical server. The initiator sends iSCSI commands over the IP network to the target, which responds with storage data, essentially creating a remote disk experience. iSCSI offers numerous benefits, making it a popular choice for businesses. It's cost-effective because it uses existing Ethernet networks, unlike fiber channel, which requires costly infrastructure. It's highly scalable, so you can easily add more storage without significant changes to your network. Flexibility is another advantage, as storage can be shared across multiple systems, allowing for centralized management. iSCSI offers block-level access, meaning it operates at a lower level of the storage stack and provides high performance, similar to having a local hard drive. Lastly, remote storage means you can manage your storage resources from a centralized location, even if the devices are located miles away. Comparing iSCSI to other storage technologies helps clarify its position in the IT ecosystem. Unlike NAS, network attached storage, which operates at the file level, meaning it shares files over a network, iSCSI provides block-level access. This allows more flexibility and performance in managing storage, especially for applications requiring raw disk access. When compared to fiber channel, iSCSI offers a more affordable option for businesses. Fiber channel requires specialized equipment like switches and adapters, while iSCSI works with regular Ethernet, reducing overall costs significantly. iSCSI is used in many real-world scenarios. It's used in storage consolidation, so instead of having multiple storage devices attached to individual servers, iSCSI allows centralization, making management easier and more efficient. Another advantage is virtualization. iSCSI is often used in virtualized environments where it provides storage for virtual machines by storing their disk files in a centralized storage location. It offers disaster recovery. You can replicate iSCSI storage to a remote site, ensuring that data is protected and available if something happens to the primary data center. It offers remote disk access. iSCSI allows remote offices or branch locations to access centralized storage, even if they are geographically distant from the main data center. In virtualized environments, iSCSI plays a crucial role in providing shared storage. Virtual machines store their disk files, such as VMDK for VMware or VHD for Hyper-V, on iSCSI targets, allowing these files to be accessed by any host in the cluster. This means virtual machines can migrate from one host to another without downtime, a key feature for high availability and disaster recovery in virtualized data centers. In large data centers, iSCSI provides an efficient way to manage and expand storage. It can be used to build a storage area network or SAN, where storage resources are pooled together and shared across multiple servers. Since it uses Ethernet, it's cost-effective and scalable, making it ideal for environments where storage needs are constantly growing. While our iSCSI is a flexible and cost-effective solution, security is a critical concern, especially when transmitting data over a network. iSCSI supports authentication using CHAP to ensure that only authorized initiators can connect to a target. Additionally, traffic can be encrypted to protect sensitive data from being intercepted. Finally, access control can be implemented through IP-based restrictions to control which devices can communicate with the iSCSI target. To conclude, iSCSI is a powerful tool for providing remote block-level storage access over an IP network. It's widely used in various scenarios, including virtualization, disaster recovery, and storage consolidation. With its cost-effectiveness and scalability, iSCSI is an essential solution for modern IT infrastructures. Now let's move on to the demonstration. So I'm going to install the iSCSI target server role on my domain controller, and then I will also create a disk, and then my node 1 will be the iSCSI initiator, and it will connect to the virtual disk hosted on my domain controller, and then it will be able to use that disk, and it will show as having another disk even though it's hosted on the domain controller. So let's go ahead and connect to my domain controller. My domain is called homelab.local. I will log in as my DC admin user. As you can see, this is my domain homelab.local. And first things first, as you can see, there are 2 nodes, 2 computers in my domain that I can manage, but that is not the focus of today. First things first, I will go into my disk management, and I will split my volume. I will shrink my volume to create a new disk. And this will be the disk will be my virtual disk that my iSCSI initiator will connect to. So let's just make it 15 gigabytes or 20 gigabytes, that's fine. So one gigabyte is 1024 MB, so this is about 20 gigabytes, a little less than that. So I'll click shrink. There, 19.5 unallocated. New simple volume. So it'll be called the F drive on my local device. Next. Select your file system. Next, finish. Okay, so now I have an F drive. So if you go to this PC, there's the F drive, and that'll be my virtual disk that other initiators can connect to. So next we go to Server Manager. We'll go to Manage, Add Roles and Features. Next. We will go to File and Storage Services. Go to File and iSCSI Services. Select iSCSI Target Server. So this will provide services and management tools for iSCSI targets. We click Next. It selected the features necessary in order to install this server role. So these are already pre-populated as soon as we select our role. Next. Install. This will take a moment to install. The installation has succeeded, so we'll close. Next, we'll go to File and Storage Services, select iSCSI, and now we're going to create an iSCSI virtual disk. So we clicked here. The F drive the F volume will be the iSCSI. Here it is asking us to specify the iSCSI virtual disk location. So remember, that'll be our F drive that we just created. Click next. We will give it a name. I will call it vdisk, but this can be any name that you wish. Click next. I will use the full 19.4 gigabytes. That'll be the size of my virtual disk. Click next. This is a brand new iSCSI target. It won't be added to a existing iSCSI target. Click next. We specify a target name, so I will just call this target 1. Click next. Next, we got to specify the iSCSI initiator that will be able to access this iSCSI virtual disk. So in order to do this, we need to enter the IQN. Now you might be thinking, how do we get the IQN? So my initiator will be node 1. Node 1 will access the disk hosted on DC. So we got to log into node 1 quickly. Node 1 is already domain joined to my home lab directory. So keep in mind this is all happening within an Active Directory domain. So this is my node 1. So I will go to Server Manager, go to Manage, go to Tools, go to iSCSI Initiator, go to Configuration, and this is the IQN that it is asking to specify in order to specify our list of iSCSI initiators that we will give access to the iSCSI target. So we copy this, go to our domain controller, and just paste that here. As you can see, it shows node 1, which is what I named my other server. Click OK, click next, and click create. Click close, and now you can see we have our iSCSI target, but it is not connected. Let's go ahead and connect to it. So we'll go to, once again, we're back here at the iSCSI initiator properties. That's still open. Remember, go to tools and iSCSI initiator. So for target, we'll just put in DC, and it'll be able to find that target since we added it to the list of targets that we can connect to. So it's connected. Click done, and there, our DC target is connected. This is my earlier target that I made, so that should have connected successfully. It's already, so if we go back to our domain controller and we hit refresh, or if we refresh this, oh, first we need to okay, so our DC, our target is connected. We just click OK. Okay, now let's go back to our domain controller. We just need to click refresh, and there, now the target status is now connected. Now you might think, okay, if we go to node 1, we should see another drive here. But if we go here, we don't see the 20 gigabyte drive. This is a different volume F. That's from my, this is offered by my node 2 in my server, but there should be a 20 gigabyte drive here, and it's not there yet. So the way, but it actually is here. If we go to disk management, we now have a new disk to initialize. So see here, disk 3, 19.4 gigabytes of unallocated space. So we just need to initialize this disk and create a simple volume on the disk. So we're going to use the whole 19.3 gigabytes. We'll call it the G drive. Click next, select the NTFS file system, and click finish. And there you have it. So now we have the G drive. This is brand new drive. We didn't add more space or increase the size on this server. This drive is being hosted completely on our domain controller on a whole nother server, but it is available for use on this server. So we can go and use it as any other storage space, any other drive. We've successfully set up an iSCSI target and initiator and have connected the initiator to a brand new virtual disk hosted on the target. By now, you should have a clear understanding of how iSCSI allows you to remotely access storage over a network, making it appear as though the storage is physically attached to the initiator system. This setup is not only useful for adding additional storage to a system, but also provides flexibility in creating shared storage environments, such as in virtualization and in disaster recovery scenarios. With iSCSI, you can easily scale your storage and centralize management, all while utilizing existing network infrastructure. If you followed along, you now have a functional iSCSI setup, and you are ready to explore more advanced configurations and real-world use cases. And I hope it has helped you understand the potential of iSCSI in managing and expanding your storage resources. Thank you for watching. If you found this tutorial helpful, please consider subscribing for more tech tutorials. Have a great day and happy learning.